We're going to look more in depth into the $Bitmap file. So I've got a newly formatted NTFS volume. You can see here's the metadata files associated with it. I'm going to click on the $Bitmap, and you will see here's all the clusters that are being allocated. So these first set of clusters, because they're all FF, indicating that those are all allocated clusters. So this first byte, okay, 1 byte, 8 bits, is representing 8 clusters, 0 through 7. Next byte will do 8 through 15, 16 through 23, and so forth. We come down to the last one, and we want to figure, okay, which clusters are we referencing here? So we're going to take that offset, so it's in hex in FTK Imager, so we have to convert that. So we're going to go from hex B0, and that gives us a decimal 176. So we're going to take that value, multiply it by 8. We have 8 clusters are being referenced, and we get 1,408. So this 1 byte is referencing clusters 1,408 through 1,415. And because it's FF, it means all of those bits are set to 1. All of those clusters, 1,408 through 1,415, are all allocated. So now we want to add a file and see how that impacts. So let's open up our E drive. You see we have nothing listed on it right now. Oops. And I will find a file. I want a file that's we'll take a look at this one. So you've seen the properties here. This is 14,071 bytes. And remember, our cluster size in NTFS is 4,096. So this should use 4 clusters. And the physical size tells us that that's what it's using. It's using 16,394 bytes physically, which is 4 full clusters. Okay. So I'm going to copy this file onto our E drive. I will minimize that. And now I'm going to re-add that volume. And expand it out. And you see now we show that file here. Let's go back into our $Bitmap. And you'll see now we have an additional byte being used. Okay. And we get a value of 1F. So again, this offset was 176. So this offset is going to be 177. So if I clear 177 times 8 equals 1416. So this byte is referencing clusters 1416 through 1423. So if we have 1F, that means our bits so this indicates that we're allocating cluster 1416, 1417, 1418, 1419, and we have a 5th cluster, 1420. Now we said we only needed 4 clusters for this file, so it would be these first 4, most likely for these first 4 clusters. And this 5th one is being used by another entry. That's most likely a directory entry for that, but it's not associated with this file. Now, unlike FAT, where we use pointers that this cluster pointed to the next cluster to the next one, we don't have that. All we know is whether or not it's allocated or not. So I'm going to go back into FTK Imager. I'm going to click on our file, and you'll see our starting cluster here is 1416. And that's exactly what we saw here. Okay. And our physical size, 16,384. 16,384 divided by our cluster size, which is 4,096, exactly 4. Okay? So those are our 4 clusters that we're using here. So that means this cluster here, again, is associated with some other file or entry. We don't know what that is at this point. Okay? So again, if we come back, I'm an FTK Imager. If we want to know what any one of these bytes in the $ bitmap, which clusters it's referencing, and I will just take this as an example. So this is byte hex 120, so 121, 122, 123, 124, 125. Let's use this one. So which clusters is that representing? So I'm going to come back to my calculator. Hex. Now make sure you're using hex 125. So that's decimal 193. Excuse me, 293. Can't read properly. 293 times 8. So it says this particular byte is referencing clusters 2344 through 2351. Sorry, so 44, 45, 46, 47, 48, 49, 50, and 51. Okay. Math is fun. Alright, so this is how you figure out what the bitmap is doing and how you figure out which clusters are being allocated or not. So there will be some questions on that.